Welcome back, chemistry students. Today we are on day 6 of our Unit 8 notes. We are going to be predicting products with combustion and redox. So the first thing we're going to start off with today is combustion reactions. We are going to learn how to write out their products when we are given the reactant, the hydrocarbon, or one of our reactants, the hydrocarbon. So the important thing to note when you have a combustion reaction and when you are trying to identify one is that you are going to need to look for a hydrocarbon formula and the words burning or combustion if you are given a word equation. So your hydrocarbon is just going to be this compound here made up of hydrogen and carbon. The subscripts that go with them will vary, but if you see, for example, a compound like C5H12, you need to be thinking hydrocarbon and combustion because a hydrocarbon will be involved in a combustion reaction. The other thing you need to be careful about is when you go to write out your combustion reaction, you need to make sure that you always write oxygen as a reactant in these reactions. So down here I'm given this hydrocarbon, C5H12, and this addition symbol. I need to make sure when I write out my reactants, I am including oxygen as one of those reactants. And I'm going to leave a little bit of space in front of oxygen so I have room to place coefficients and balance this later. So we have our reactants, our hydrocarbon, and our oxygen, and now we need to put our products there. Combustion is fairly straightforward and will hopefully not be too challenging for you to predict the products of because the products will always be the same. So right here I have underlined our products, CO2 and H2O, because every single combustion reaction will have these two compounds as the product. So I'm going to write my products here. For example 1, carbon dioxide and H2O. Carbon dioxide and water. We're going to produce these as products of our combustion reaction. So now we have written out the skeleton equation. For example 1, we are going to balance this. I'm going to go about balancing this in a way that is hopefully going to be helpful for a lot of you. The most challenging part of a combustion reaction is balancing. So what I always tell students to do is to go ahead and start off by placing a coefficient of 2 in front of their hydrocarbon. The way I am about to show you will work for all your combustion reactions. Just go ahead and place a 2 in front of your hydrocarbon, and then underneath my arrow I'm going to list my 3 elements involved in this reaction: carbon, hydrogen, and oxygen, in that order. This is the order I'm going to go about balancing. Now that I have listed my elements down here, I'm going to figure out how many carbon, hydrogen, and oxygen I have on both sides. I have 10 carbon over here, and I have 24 hydrogen. I have 2 oxygen, and then on my other side of my equation, I have 1 carbon, 2 hydrogen, and 3 oxygen. You have to be careful when you're counting your oxygen over here because you have oxygen in both CO2 and H2O. So now that I have these listed out, I'm going to go ahead and balance. Like I said, I'm going to balance in the same order I wrote here, and I'm just going to write it down here as well so we can check them off as we go. We're going to balance carbon first, then hydrogen, then oxygen. So since we have our carbon up first, I'm going to try and get 10 carbon on both sides. So I'm going to place a coefficient of 10 in front of my CO2. That will increase my number of carbon to 10 on this side. It will also increase my number of oxygen. So now I have 20 oxygen coming from this part of my equation, and this one other oxygen over here. So at the moment I have 21 oxygen. So we have now balanced our carbons. Next up, we're going to balance our hydrogen. I see that I have 24 hydrogen over here. I would like to have 24 over here as well. So I'm going to go ahead and place a 12 in front of H2O. That will get my hydrogen to 24 on both sides. That will also impact my number of oxygen. So I'm going to have 12 oxygen coming from this part of my equation now. So in total, I now have 32 oxygen atoms on the right side of my equation. Since I have this 32, I'm going to write that there. We have balanced our hydrogens. They are equal on both sides. Last but not least, we are going to do oxygen. So I have 32 oxygen on this side of my equation. I need 32 over here as well. So I'm going to go ahead and place a 16 in front of my oxygen. That will increase my number of oxygen to 32. We are now fully balanced, but the last thing I want to do is reduce. So I see that all of my coefficients in this combustion reaction can be divided by 2. If all of your coefficients are even, can be divided by 2, you need to do that. You need to go ahead and reduce. So I'm going to do 2 divided by 2 and get 1. 16 divided by 2 and get 8. 10 divided by 2, get 5. 12 divided by 2, get 6. Now we have fully reduced our chemical equation here. The coefficients are reduced, and this is my final answer. If you do not reduce, that is going to be half off on your quiz and your tests. So please make sure you are reducing. If you end up with an odd number here, we're going to do an example like that here in a second, you don't need to reduce. But if all of your numbers are even, please make sure you are reducing. Okay. So moving on to example 2, we see we are given this hydrocarbon, C4H10. So we're going to go ahead and add our other reactant, oxygen, and our products, CO2 and H2O. I'm going to do the same thing. I'm going to list my elements. And I'm going to place a 2 in front of my hydrocarbons. So again, we're going to find out that we have 8 carbon, 20 hydrogen, and 2 oxygen on the reactant side. And we have 1 carbon, 2 hydrogen, and 3 oxygen on our product side. So I'm going to balance in the same order that I balanced over here. Carbon, hydrogen, then oxygen. So I'm going to place an 8 in front of CO2 to make sure I have 8 carbon atoms on both sides. I will place a, before we go about hydrogen, we need to make sure we change the number of oxygen. That will get me 16 oxygen plus this 1 oxygen here. So we are now at 17 oxygen. Our carbons are balanced, and we can move on to hydrogen. For hydrogen, I have 20 over here and 2 over here. So I'm going to place a 10 right there. That will get me to 20 hydrogen. That will also get me 10 oxygen. 10 times 1, oxygen there gives me 10 oxygen. So now I have 26 oxygen. And I have balanced my hydrogen. So I'm going to go ahead and balance my oxygen. 26 divided by 2 is 13. So I'm going to place a 13 here. That will get me 26 oxygen on both sides. And then my last step, I'm going to check if I can reduce. This number is an odd number. Since our coefficients have to be whole numbers, I cannot divide this 13 by 2 and get a whole number. So I'm not going to reduce. This is my final answer in this case. You only divide everything by 2 if everything can be divided by 2 and provide you with a whole number. Since that is not the case here, we are done. Okay. And our final example here, example 3. Again, we have this hydrocarbon. We're going to make sure we add our other reactant, oxygen, and our products, CO2 and H2O. I'm going to list my elements under here and place a 2 in front of my hydrocarbon. Every time. Just place a 2 there. It makes it easier on your life. So we have 20 carbon, 44 hydrogen, and 2 oxygen on this side. 1 carbon, 2 hydrogen, and 3 oxygen on this side. Same thing. We're going to balance carbon, then hydrogen, then oxygen. So I will place a 20 in front of my CO2. That will also increase my number of oxygen. Now I have 41 oxygen, but I balanced my carbon. I'm going to go balance my hydrogen. I'm going to place a 22 here to get me to 44 hydrogen. That will also get me 22 oxygen. So in total, on my right side of my equation, I'm going to have 62 oxygen. I have balanced my hydrogen, and I'm going to come over here and now balance my oxygen. 62 divided by 2 gives me 31. So I'm going to place a 31 in front of my oxygen. Again, I'm going to check if I can reduce. Since 31 is an odd number, it is not divisible by 2. We are going to go ahead and say that is our final answer.